Hi guys, welcome to another episode of MrLopezClasses.com. In this episode, I am going to talk about charging systems, alternators, battery chargers, solar panels. Those are charging systems. All of them are used to keep the charge on the batteries. Yes, you can keep the charge of your batteries fully charged with solar panels. Yeah. The solar panels produce DC current. The positive and the negative goes into the a.c.r, and after the a.c.r into the batteries in order to keep the batteries properly charged. Yes, when you have a solar panel, in between the solar panel and the battery, you have an a.c.r or regulator. Check the chapter 17 of your Marine Electrical Handbook, and the chapter 17 is dedicated to solar panels. I am going to explain in that chapter how the solar panels should be selected and how the solar panels could be configured in series or parallel in order to store us more amps in a short period of time. Yes, you can charge the batteries with solar panels. You can charge the batteries with battery chargers like this. This is a marine battery charger. Right now we are going to talk about that. And also you can charge the batteries in your boat, in your car, in your motorcycle, in your airplane with the alternator. The alternator is the element that immediately you start the engine, that element starts to produce electricity and keep the charge of the batteries fully charged. This is an excellent equipment in order to charge the batteries. Yes, all of those are sources of DC current. All of those elements, the solar, the battery charger, the alternator, those elements are sources of DC current. And you can keep the charge of the batteries fully charged with any of those systems or with all of them integrated. Yeah, this is the chapter 17. How can I integrate my solar panel system with the rest of the charging system in the boat? It's very, very simple. All right, my friends. Now we are going to be concentrated in the alternator. How the alternator produces electricity. The alternator produces electricity basically because the magnets, because electromagnetism. And this is the principle to produce electricity. Yes, my friends, inside of the alternator in the first step produces AC current. And after that, that AC current is rectified into DC. How? With an element called the rectifier or the bridge of diodes. We are going to do the project of the rectifier in our course of electronics. This is a project that we are going to build. With a circuit board, we are going to create the circuit, and we are going to fabricate that circuit in the laboratory. This is a project that we are going to solve it in the course of electronics. Check that episode in the videos related with the electronic books charging system. All right, the alternator. We are going to start to checking internally in the alternator how the alternator produces electricity. If you understand how the alternator produces electricity, it's easy for you in the future troubleshoot any type of problems with the alternators. Try to diagnose the problem is on the regulator, on the excitation, the problem is the diodes. Yeah. It's easy follow the troubleshoot if you understand how the alternator produces electricity. Okay. Suppose that you have a piece of rod. Suppose that you have a piece of rod, a piece of iron like this. Remember, iron is the only metal with magnetic properties. You remember the periodic table? Iron have magnetic properties. This is the only metal with those properties. Because the iron is that we have computers, that we have electricity, that we have all the appliances depend on the electricity, and this is possible only because the iron and the magnetic properties of the iron. All right, we are going to convert a piece of iron in an electromagnet. We are going to separate the positive charge of the piece of iron and the negative charge in other side. And we are going to convert one piece of iron regular in an electromagnet with positive charge in one side and negative charge in the other side. How can you do that conversion? It's simple. If you have the piece of iron, like the iron that you have on the screen, and you can cover the middle of the iron with a plastic or isolator material, and after that you wrap it a coil over the plastic. Then we are going to connect one end of the coil to the negative of a battery and the other end of the coil to the positive of the battery, interrupted by a switch, interrupter or switch. Okay, right now when I close the switch, when I turn on the switch, when I close the contact on the switch, immediately the current passes through the coil, and for induction, for electromagnetic induction, the current separates the positive charge in one side and the negative charge in the other side. Right now you have in this example a concentration of positive charge in one side and a concentration of negative charge in the other side. This is possible only because the rod of metal is iron. With iron it's possible to separate the charge in positive in one side and negative. What happens if I open the switch? If I interrupt the current? Immediately the magnetic properties in the piece of iron disappear, and right now the iron returns to the original position with no magnetic properties. The name of that piece of iron is electromagnet. Electromagnet because the magnetic properties depend of the power in the coil. Yeah, this is an electromagnet. Oh, Mr. Lopez, I know magnets that they don't need to be powered. Oh, those are permanent magnets. In the chapter 11 and 12, we are going to use those magnets in order to understand how the motors, AC motors and DC motors spin, how the motors works. All right, what is the difference between the electromagnet and the permanent magnet? The difference is in the quality of the iron. In order to produce an electromagnet, you need a soft iron, like a cast iron. In order to create permanent magnets, the procedure is the same, with a coil and power, but the metal is a hard steel. It's a steel with a high content of vanadium. Those steels storage or keep the separation of charge for a long period of time. Those magnets are considered permanent magnets. All right. Right now, for our example, we are going to use electromagnets. All right. Right now, the piece of iron, the rod of iron, is electromagnet with the positive charge in one side and the negative charge in the other side. Suppose that I wanted to install a washer. I want to weld one washer in each side of the piece of rod. I wanted to weld one washer, big washer, metallic washers in iron in each side, one in the positive side and other one in the negative side. But before I install those washers, or I welded those washers in each end of the rod, I am going to cut it each washer in this way, exactly in this way, with those bits, with those sections. And right now, those washers are welded in the rod. Okay, now I am going to bend the washers. I am going to bend the washers, and the final product is like this. Is like this, like the picture that you have on the screen. Oh, remember, don't forget, the coil right now is inside of the bended washers. The coil right now, the final product is this: positive, negative, positive, negative, positive, negative, and the coil is located inside of the bended washers. How I connect, how I keep the coil with power internally? Oh yeah, because I am going to install a couple of slip rings. The slip rings are located in one end of the rod. The slip rings are separated from the center of the rod with a plastic material. In other words, the slip rings in copper, they don't touch the rod in the center. The slip rings in copper pass through the washers and enter in the coil and keep the coil with power. What is the function of the slip rings? When the alternator is spinning, the slip rings are in permanent contact with the pieces of carbon or brushes, like the brushes that you have on the screen right now. Those brushes are connected in permanent contact with the slip rings, and those brushes, one brush is connected to the negative side of the battery, and the other brush is connected with the positive source of power, normally from the ignition switch. The power coming in the positive side of the slip rings is coming from the ignition switch. In other words, when you activate the ignition switch in ignition position, the power enter in the positive brush and enter in the coil, power the coil, and return to the negative brush into the negative of the battery. This is the process. It's very, very simple. Okay, right now, when the coil in the middle is fully powered, the magnets are strong magnets. And now, the name of those magnets, spinning is the rotor. The rotor is composed for the electromagnets and the coil inside of the electromagnets. The area where the brushes and the slip rings are located is brushes and slip rings. This is the exciter or commuter. This is the commutation area or exciter or commuter, this area. And all the element in constant rotation is the rotor. Okay, suppose right now that I locate around the rotor one coil like this. One coil like this. Look, the copper enter here, goes over there, and finish here. This is the beginning and this is the end. The middle one is connected with the frame, the iron in the center. The middle one is connected with the frame. Oh, the coil never touch the frame in iron because it's separated for isolator materials. Normally it's plastic or bakelite. This plastic isolates the copper from the iron in the frame. Additionally, the wire is wrapped, the coil is wrapped, and the wires, they don't touch one with the other one because the wire is covered for varnish, and the varnish normally is an epoxy resin. The epoxy resin in between the wires avoid that the wire touch and make a short. Yes, if you check continuity between this end and this end, you have continuity. Beep. It's because this is the beginning of the coil and this is the end of the coil. Alright? Suppose that you have this coil around the rotor. In other words, the rotor is spinning and the stator is fixed. What happened when the rotor is spinning at high speed? When the rotor is spinning at high speed, you remember in physics the centrifugal force. For centrifugal force, some electrons jumped into the coil. Immediately the electrons, the positive charge, negative charge, and the positive charge jumped into the coil. You register a sine wave, positive charge and negative charge, positive charge and negative charge. Perfect. what happens if I connect in between this terminal and this terminal one light bulb, like the picture right now? And what happens if the rotor is spinning? If the rotor is spinning and in front of the coil. If the rotor is spinning in front of the coil, the light bulb starts blinking and produce electricity. This is exactly the same like the example that I have on the screen right now. That you bended this electromagnet like a horseshoe, and you approximate the magnet to a coil, and the coil is connected with a light bulb. Depending on the speed of your hand in front of the coil, the light bulb produces electricity. Okay, this electricity produces for the rotor spinning in front of the coil or your hand in front of the coil is AC current. Yes, my friend, right now you discover how to produce AC current. It's simple. It's basically the rotation of electromagnets in front of a coil. When the electromagnets are spinning at high speed in front of the coil, the charge jumps into the coil and produce the signal positive and negative, positive and negative. Each time that one magnet passes in front of the coil, if the magnet is the negative portion of the magnet, produce the negative side of the signal. If the magnet is the positive side of the magnet, produce the positive side of the signal. And once again, other positive and other negative, and once again, other positive and other negative. It's very simple. This is the form to produce AC current. Okay, right now you have AC current. Okay, with the AC current, because that AC current depends on the rotation of the rotor. And where is located the rotor? The rotor of the alternator have a pulley, like the pulley that you have on the screen, and the pulley is connected with the crankshaft of the engine by means of a valve. The pulley of the alternator is connected with the pulley of the crankshaft with a valve. Yeah, when you accelerate the engine more or less, you produce more or higher or lower voltage. Okay, this is the voltage produced here. Oh, but the high or low voltage depends on the acceleration of the engine. How can I stabilize that voltage in order to keep a constant voltage? With the voltage regulator. For that reason, those ends, positive, hot, neutral, and ground in the middle, are connected to the voltage regulator. And at the end, after the voltage regulator, those three elements enter into the bridge of diodes or rectifier. The bridge of diodes, we are going to study later, rectify the AC current, the AC signal, and convert the AC signal into DC straight signal. And finally, in the other side of the alternator, you have positive and negative DC. Bingo, finito. Is clear? We are going to refresh quickly the process. The alternator, the electromagnets, how you get electromagnets? You bring the power passes through the brushes touch the slip rings, and the slip rings power the coil inside of the washer suspended, and when the coil is powered and the rotor is spinning, the magnets become in electromagnets. Okay, when the electromagnets are spinning in front of the coil receives positive charge and negative charge and register the AC signal. Right now, the AC signal is stabilized with the voltage regulator, and after that, in the output of the voltage regulator, you connect the bridge of diodes, and the AC current is rectified into DC. And in the output of the alternator, you have DC output, positive and negative. The negative goes to the negative of the negative bus bar, and the positive goes directly into the a.c.r. And from the output of the a.c.r, you have the connection per each battery bank. This is the procedure to produce electricity with the alternator, and this is the procedure to keep the charge of the battery banks with the alternator. How I know if my alternator is working or not working? In a simple way. For example, in your car, how can you check if the alternator is working? It's simple. You check the voltage of the battery directly on the battery with the multimeter selected in volts DC. All right, you check the voltage and you register 13.2. Okay, right now, other person start the engine and you continue with the multimeter connected in the positive and negative terminal of the battery. If the voltage increase and pass 13.5, 13.7, 14.1, is because the alternator is running. If when you start the engine, the voltage stay the same or decrease a little, it's because the alternator is not working. It's pretty simple. Yeah? Okay. If the alternator is not working, there are different possibilities. One possibility is the valve is broken, or the tension on the valve is not appropriate. The valve is loose. That's the most common problem. Or internally in the alternator you have problems. What type of problems? For example, the excitation is not good. Right now we are going to talk about that. Or the bridge of diode is broken, or the regulator is not good. Let me explain how can you determine which is the problem specific. All right, suppose that the alternator is producing excessive voltage. Normally, the output of the alternator in typical condition should be in between 13.7 volts and 14.1 volts DC for a 12 volts alternators. There are alternators for 24 volts, and the output is around in between 20.7 and 26.4, something like this. All right, but in 12 volts, the output should be in between 13.6 and 14.1, 14.2 volts DC. Suppose that the alternator is producing excessive voltage. It's not producing 14.2, it's producing 16 volts. What is the consequence? If you don't have a.c.r, if you connect the output of the alternator directly into the positive of the battery, probably the batteries are overcharged. What is the symptom when the battery is overcharged? The battery is too hot and the electrolyte is evaporated, and you need to recover frequently the level of the electrolyte in the battery. This is the consequence when the alternator is producing excessive charge. Alright, in that case, if the alternator is producing excessive charge, normally it's because the voltage regulator is working improperly, not regulate, and the voltage goes up. This is a typical consequence of a bad voltage regulator. Is possible to replace the voltage regulator? Yes. If you go to a matching shop specialized in alternators and star motors, they replace the voltage regulator. Can you do that? Yes, if you have experience. It's easy to damage the alternator? Yes. If you don't have experience, it's possible to damage the generator. But you can practice. If you have an old alternator and you want to learn the procedure to replace the brushes, to replace the voltage regulator, the bridge of diodes, you can practice. You can order online those parts and you can replace. But if you are in an emergency and you need to solve the problem, go to a specialized machine shop and they replace the voltage regulator or the part damaged for use. Okay, this is the typical consequence when the voltage regulator is damaged. Other common complaint is the output of my alternator is too low. It's producing only 12 volts or 11.7 volts. Normally the alternator should be producing in between 13.6 and 14.2. Or no, the alternator only produces 11.7 volts. It's producing, but the voltage is too low. With that voltage, you can charge the batteries? No, because that voltage is below the voltage recommended. All right. What is the consequence? Why the output is low voltage? Normally it's because the excitation is a poor excitation. What is the meaning of that? The connection in between the brushes and the slip rings is contaminated with oil, or the brushes are gone, are completely eroded, and the contact in between brushes and the slip rings is not good. If the contact is not good, the magnets are weak magnets, and the alternator produce low voltage. That's okay. Normally, a low output voltage is the consequence of low excitation. Low excitation is probably bad brushes or slip rings contaminated with oil, and the isolation in between the brushes and the slip rings produce an output low voltage. Other typical scenario is, the output of my alternator is intermittent. When I connect a light bulb, the light bulb is intermittent. You have probably one problem on the diodes, on the bridge of diodes. One diode is broken or in short. You need to replace the bridge of diodes. My alternator produce good power if I accelerate too much, and low if I decelerate. High acceleration, good intensity. Low acceleration, low intensity. This is once again contamination in the commuter, in the excitation area. Probably too much oil, bad brushes. This is once again problem of excitation. The excitation is a poor excitation. Alright, those are the most typical problems related with the alternators, and you can solve it in this way. Other common problem is I replace my alternator for a new one with the same characteristic that the previous one. However, my new alternator produce excessive voltage and keep my batteries too hot. This is a very common problem when the new alternator have a smaller pulley. Yes, because the pulley on the new one is smaller, the alternator is spinning faster and probably produce more voltage and charge the batteries faster. Be careful with the output of the alternator, the diameter of the pulley. Replace the pulley if it's necessary, and you solve all of those problems.